Hello my dear students, today let us discuss about another field method, that is standard penetration test. You can see this figure. This is a typical setup for standard penetration test assembly. Here there is a split spoon sampler, and this is a borehole, and this is a tripod, okay, and hammer of 65 kg is used, which is at a height of 750 mm. The standard penetration test is carried out in a borehole, while DCPT and SCPT are carried out without a borehole. DCPT is dynamic cone penetration test and SCPT is static cone penetration test. There are three penetration tests: standard penetration test, dynamic cone penetration test, and static cone penetration test. The standard penetration test is carried out in a borehole, while other two methods are carried out without a borehole. All the three tests measure the resistance of the soil strata to penetration by a penetrometer. Useful empirical correlations between penetration resistance and soil properties are available for use in foundation design. This is the most extensively used penetrometer test and employs a split spoon sampler, which consists of a driving shoe, a split barrel of circular cross-section which is longitudinally split into two parts, and a coupling. IS 2131-1981 gives the standard for carrying out the test. You can refer IS 2131-1981, which gives a detailed and clear picture of this penetration test. The procedure: the borehole is advanced to the required depth and the bottom cleaned. The split spoon sampler attached to standard drill rods of required length is lowered into the borehole and rested at the bottom. The split spoon sampler is driven into the soil for a distance of 450 mm by blows of a drop hammer of 65 kg falling vertically and freely from a height of 750 mm. The number of blows required to penetrate every 150 mm is recorded while driving the sampler. The number of blows required for the last 300 mm of penetration is added together and recorded as the N value at that particular depth of the borehole. The number of blows required to effect the first 150 mm of penetration, called the seating drive, is disregarded. The split spoon sampler is then withdrawn and is detached from the drill rods. The split barrel is disconnected from the cutting shoe and the coupling. The soil sample collected inside the split barrel is carefully collected so as to preserve the natural moisture content and transported to the laboratory for tests. Sometimes a thin liner is inserted within the split barrel so that at the end of the SPT, the liner containing the soil sample is sealed with molten wax at both its ends before it is taken away to the laboratory. This is a setup on the field. Okay, the SPT is carried out at every 0.75 meter vertical intervals in a borehole. This can be increased to 1.5 meter if the depth of the borehole is large. Due to the presence of boulders or rocks, it may not be possible to drive the sampler to a distance of 450 mm. In such a case, the N value can be recorded for the first 300 mm penetration. The boring log shows refusal and the test is halted if 50 blows are required for any 150 mm penetration and 100 blows are required for 300 mm. This is not 300 meter, 300 mm penetration. 10 successive blows produce no advance. Okay, so you can see here this is a crown sheave or pulley, and typically 1 inch 25 mm diameter and rotating cathode, and this is the hammer here, slip or guide pipe, and drill rod. This is a ground surface, and here it is a borehole. Okay. Precautions. There are some precautions that have to be taken during this test. That is, the drill rods should be of standard specification and should not be in bent condition. The split spoon sampler must be in good condition, and the cutting shoe must be free from wear and tear. The drop hammer must be of the right weight, and the fall should be free, frictionless, and vertical. The height of the fall must be exactly 750 mm. Any change from this will seriously affect the N value. The bottom of the borehole must be properly cleaned before the test is carried out. If this is not done, the test gets carried out in the loose, disturbed soil and not in the undisturbed soil. When a casing is used in borehole, it should be ensured that the casing is driven just short of the level at which the SPT is to be carried out. Otherwise, the test gets carried out in a soil plug enclosed at the bottom of the casing. When the test is carried out in a sandy soil below the water table, it must be ensured that the water level in the borehole is always maintained slightly above the groundwater level. If the water level in the borehole is lower than the groundwater level, quick condition may develop in the soil and very low N values may be recorded. In spite of all these imperfections, SPT is still extensively used because the test is simple and relatively economical. It is the only one test that provides representative soil samples both for visual inspection in the field and for natural moisture content and classification tests in the laboratory. Advantages of standard penetration tests are relatively quick and simple to perform. Equipment and expertise for test is widely available, provides representative soil sample, provides useful index for relative strength and compressibility of soil, able to penetrate dense and stiff layers. Results reflect soil density, fabric, stress strain behavior. Numerous case histories available. Disadvantages of standard penetration tests are requires the preparation of borehole. Dynamic effort is related to mostly static performance. SPT is abused. Standards regarding energy are not uniform. If hard stone is encountered, difficult to obtain reliable result. Test procedure is tedious and requires heavy equipment, not possible to obtain properties continuously with depth. SPT values obtained in the field for sand have to be corrected before they are used in empirical correlations and design charts. As per IS 2131/1981, it recommends that the field value of N be corrected for two effects, namely the first one is effect of overburden pressure and second one is effect of dilatancy. The first one will see correction for overburden pressure. Several investigators have found that the penetration resistance or the N value in a granular soil is influenced by the overburden pressure. Of two granular soils possessing the same relative density but having different confining pressures, the one with a higher confining pressure gives a higher N value. Since the confining pressure, which is directly proportional to the overburden pressure, increases with the depth, the N values at shallow depths are underestimated and the N values at larger depths are overestimated. To allow for this, N values recorded from the field tests at different effective overburden pressure are corrected to a standard effective overburden pressure. The corrected N values given by N dash, that is equal to Cn into N, in which N dash is corrected value of observed N. Cn is correlation factor for overburden pressure. Okay, so this is about the correction factor for overburden pressure. So whatever the value you get in the field, that is N value, it has to be corrected. That is given by this equation. N dash is equal to Cn into N, where Cn is the correlation factor for overburden pressure. That is constant value. I mean, it is different for the different types of the soils, and N value is the obtained value. So you will get the corrected value of N. Second test is correction for dilatancy. Dilatancy correction is to be applied when N dash obtained after overburden correction exceeds 15 in saturated fine sands and silts. IS 2131-1981 incorporates the Terzaghi and Peck recommended dilatancy correction when N dash is greater than 15 using the equation, this equation N double dash equal to 15 plus 0.5 of N dash minus 15, okay, where N double dash is the final corrected value to be used in the design charts. If N dash is less than or equal to 15, N double dash is equal to N dash. Okay, if N dash is less than or equal to 15, then you can take N double dash is equal to N dash. But if N dash is greater than 15, then is an indication of a dense sand. In such a soil, the fast rate of application of shear through the blows of a drop hammer is likely to induce negative pore water pressure in a saturated fine sand under undrained condition of loading. Consequently, a transient increase in shear resistance will occur, leading to a SPT value higher than the actual one. So this is about corrections for dilatancy. So SPT is one of the very important test commonly used, and split spoon sampler is used for this test, and mainly two type of corrections: correction for overburden and correction for dilatancy. You can refer IS code. It gives a clear picture and a detailed procedure of this test. I hope all of you understood. Thank you.